Hello, I am Unsunam. I'm currently with ETRI. ETRI is an acronym of Electronics and Telecommunications Research Institute. Today, I'm very happy to present the collaboration projects of developing Frontal coherent optical receiver module for fiber optics-based 5G networks. This is the content of my presentation. Actually, I'm introducing the ETRI overview, followed by a proposed collaboration project. This is the ETRI overview. Actually, ETRI was founded in 1976 by the Korean government for developing the ICT technologies. Actually, ETRI is located in the Daejeon area of the Korea. Actually, Daejeon is located from 1 hour drive from Seoul area to the south. The scope of the R&D area covered by ETRI is very broad, from the ICT R&D to the standardization activities. Also, strategic planning for the national R&D policy and the engineering support for the small and medium-sized enterprises. This is organization of ETRI. Actually, ETRI consists of four huge research labs, so-called Artificial Intelligence Research Lab, Telecommunication and Media Research Lab, Intelligent Convergence Research Lab, and ICT Creative Research Labs. Each lab has around 500 R&D steps. And these four research labs are supported by three major departments, so-called planning division, administration division, and the small and medium-sized enterprises and the commercialization divisions. We have two overseas offices. One is located in the Beijing, in China, and the other is a USA office in the Santa Clara, in the California. Now, this is the status of the personnel and R&D budgets of ETRI. As ETRI is the largest government research lab in Korea, we have so many R&D steps, as many as around 2,300. Among them, 82% is R&D steps, 5% is a technical step, and 20% is administration steps. Also, we have spent so much R&D budgets every year, as much as 579 million US dollars. Among them, 85% of the total budget comes from the government, and 3% from the private sector funding. And the most important R&D budget comes from the loyalty and the others, comprises 11% from the companies. This is the innovation ecosystem of ETRI. As I said before, ETRI is a government research labs. The government supported in terms of the R&D budget and the policy, ETRI, to make a new ICT technologies. For the ETRI side, we have to transfer the developed technology to the local company and overseas companies to have a loyalty incomes. So we have collaborating with many companies domestically and internationally. This is the major achievements of ETRI up to now. For the 40 past years, we have developed many important ICT technologies for the Korea, which includes TDX. This is the first time division exchange systems for the telephone, and CDMA and LTE 5G for the wireless telecommunications, OLED, AM OLED for the display technologies, and TikTok. This is the real-time language translators using the artificial intelligence technologies. And we are firstly developing the fiber optic technologies for the 5G. As ETRI is a government research lab, ETRI is evaluated every year by the government in terms of three packs. Those are SCI paper, patent, and the number of technology transferred to the local companies. This is the standardization and SCI paper status. Over the 4 years, we issued standardization contributions as many as 5,373, and we published SCI paper as many as 552 over the 4 years. This is the status of the patent applications. We have issued around 14,000 patents over the past 4 years. This is the status of the technology transfer by ETRI to the local and overseas companies last 4 years. We transferred the developed technologies as many as 2,062 to the local and overseas companies to have a royalty income about 176 million US dollars. This is the status of the ETRI companies. We have spun off many startups and spin-offs. In the case of the startups, we have 52 startup companies and 53 spin-offs companies. These around 100 startups and spin-off companies are collaborating with ETRI to develop new ICT technologies. This is a status of the global R&D cooperation network. Actually, we are collaborating with 163 organizations of the 45 countries over the world. From now on, I'm going to talk about the collaboration project. The title of the project is Frontal Coherent Optical Receiver Module for Fiber Optics Based 5G Networks. The final goal of this project is to develop 25 gigabps to the 100 gigabps frontal optical receiver modules. And the collaboration activities include to develop and manufacture 25 gigabps to the 100 gigabps coherent frontal receiver module and design and fabrication of balanced photodiode, polarization splitter, optical hybrid, and passive elements. Now, I'm going to tell you the motivation behind this project. The picture is overall structure of the fiber optics-based 5G network. This 5G network is classified into three categories, so-called frontal link from office to the local area antenna, backward link from office to the office, and mobile connections. The baseband signal of the 5G base station is transmitted digitally using the EC3 protocol interface, whose typical rate is around 10 gigabps at present. Because of this 10 gigabps transmission speed, we cannot use full characters of the 5G networks, so-called large bandwidth, low delay, mass connections, and bandwidth flexibility. So we have to increase the data speed and the data capacity of the frontal network using new technologies. So I'd like to propose new technologies of the coherent technologies to make coherent receivers. This is one example of the 5G frontal optical link in Korea. In Korea, we have ring-type fiber optic network structures, which employs passive node-based 12-cell sites. tunable laser-based transmitter, and CWDM, coarse wavelength division multiplexing technologies, whose channel speed is 10 gigabps. These 10 gigabps transmission speed and data capacity is shared by LTE, 5G, and wired internet. So this limited transmission speed, we cannot use the full characteristics of the 5G networks. So there is a need for us to develop new technologies to increase the data rate and the data capacities. Now this is a proposed collaboration topic. 5G Frontal optical coherent receivers. To develop these small and economical coherent receivers, we have to solve many technical problems, such as the balanced photodiode, polarization, and the optical hybrid, and the receiver module packaging technologies, and frontal network structure investigations. To solve these technical problems, I'm looking for new partners. Thank you very much.